students, the next question is, obtain a Fourier expression for f of x equals x for minus pi between the range minus pi and pi. When it comes to Fourier expansion or Fourier expression, we need to understand what kind of Fourier series is it. What I mean is, I can have a Fourier series expressed using f of x. I can have a Fourier series expressed using f of omega t. Here, this is spatial domain, this is time domain. As you know, there can be a frequency domain also, because frequency is nothing but the reciprocal of time, right? So how do we write Fourier series in spatial domain? It's written as f of x equals a by 2 plus summation of n equals 1 to infinity a n cos nx plus summation over n equals 1 to infinity b n sin nx. Here a0, an and bn are Fourier coefficients. Here the Fourier coefficients a0, an and bn are given by a0 equals 1 by pi integral of f of x dx between the range minus pi and pi. An equals 1 by pi integral of f of x times cos nx dx over the interval minus pi to pi, and bn equals 1 by pi integral of f of x times sin nx dx over the interval minus pi to pi. Okay. Now you have to first understand this is the spatial domain. Suppose we have a time domain, we are supposed to write everything in terms of t. That is, f of omega t goes like, this is still a0 by 2 plus summation over n equals 1 to infinity an cos, instead of nx we should write n omega t plus summation over n equals 1 to infinity bn sin n omega t, where omega is frequency, where time is hidden. That is, omega is 2 pi divided by t. T is the time period of the oscillation or time period of the periodic function. So here again a0, an and bn are Fourier coefficients which are given by a0 equals 2 divided by t integral of f of omega t dt over an interval of 0 to t, and an is given as 2 by t integral of f of omega t cos n omega t dt over an interval of 0 and t. Also, bn is 2 divided by t integral of f of omega t sin n omega t dt over an interval of 0 to t. And one important thing is, in some cases, sometimes this constant over here, because it's a constant, can't I write it as a dash? If this a0 were just a, suppose, then can't I write this entire thing as a0? So in some books and some material, the first term, it doesn't have to be a0 divided by 2 always. It can be any constant. For that matter, it could be just a0. But if you take a0 here, this has to change. How do we get to know whether we have to use the formulas of spatial domain or time domain? Look at the range over here. If it is in terms of pi angles or something, that is in spatial domain. Sometimes it is also given like in the range 1 and 1 or something like that, or the range is 0 and 1, then it is spatial domain. If it is given in terms of t or something, if it is given in terms of time, then it is time domain. Let's clear some space here. Before I start solving, let me tell you about a verification method. You can call it as a trick or a shortcut method to understand how the Fourier expression looks like. First of all, any function that is given, you analyze whether that's a odd function or an even function. Now you tell me, what is this function? f of x equals x, whether it is an odd function or even function. How do we know that? If a function takes negative values and reproduces the negative of the original value, then it is an odd function. So the thing is, for odd functions, a0 is 0 and an is also 0. Just to recall why is that so, if you have an odd function over here, look at the limits, it's minus pi and pi. So you are subtracting the negative value of a function from its positive value, right? So obviously it gives you 0, isn't it? And look here, this is a even function. If this function is odd, the product of an odd function and an even function is again an odd function. Don't you think so? So an is taking integral of an odd function which is intrinsically 0, whereas if bn, if you check, this is an odd function, this is also an odd function. The product of an odd function and an odd function is an even function. So this will not vanish, whereas a0 and an, they both will vanish. Alright, so the steps that you have to follow to solve this is like this. You write the Fourier series is given by, or you can also write the Fourier expression is given by f of x equals this. So next is to find a0. What's a0? It is 1 by pi integral of f of x dx over an interval of minus pi to pi. Okay. Here you can also write for f of x equals x. So start simplifying. A0 is 1 by pi integral minus pi to pi x dx. 1 by pi as it is. What's integration of x dx? It's x squared divided by 2, right? Lower limit is minus pi, upper limit is pi. That is, first you substitute the upper limit pi square minus of minus pi whole squared. That is 1 by 2 pi. This is pi square minus pi whole square will be pi square, because minus into minus is plus, right? So pi square. What is this? 0, obviously. So a0 is 0 as expected. Next you write to find an. An is given by this. Substitute and solve. This has to be solved using integration by part. That is, the formula that I remember easily is this. If the integration is something like the first term and the second term and some value like dx, it could be, or dt, whatever it can be here, it is equal to, it can be whatever, okay? This can be anything, okay? So how I remember it is first into integral of second minus integral of second into differentiation of first. So here, let me take, how do we decide which one is first and which one is second is, if you integrate, it should vanish. It should be like that, okay? So if I take this as first one, differentiation of this is just dx, right? So it's easy. Whereas I take this as second, okay? Because differentiation of this becomes sin nx into n into dx. Again, it is complicated, right? So in the first go itself, it becomes dx, is it? So that's why you have to choose the first and the second functions wisely. Alright, let's continue. So as we said, this is first, this is second. Now I should write first into integration of second. Integration of cos nx is sin nx divided by n minus integration of, the limits remain the same, okay? Integration of second. We've already done that, no? We've already done that, right? That is sin nx by n, that becomes this, and differentiation of first is dx. Limits here are minus pi to pi. So an equals 1 by pi. Apply the limits here, becomes pi sin n pi divided by n minus x takes minus pi sin minus n pi divided by n minus, let me take the constant outside, that is 1 by n. Now integration of sin nx is minus cos nx. So minus cos nx divided by n. The limits are minus pi to pi. So here, let's simplify this further. You'll have pi sin n pi by n, minus into minus becomes plus pi, sin of minus n pi is minus sin n pi. So this plus becomes minus sin n pi divided by n minus, again minus into minus, this minus into this minus becomes plus, this n multiplied by this n becomes n squared. We are left with cos nx between the limits pi and minus pi and pi. So this is 1 by pi. This entire thing becomes 0 plus 1 by n square cos n pi minus cos minus n pi. Cos of minus n pi, this is a even function, right? So doesn't matter if what is inside cos is negative or positive, it remains positive. That is, cos of minus n pi is cos n pi itself. So cos n pi minus cos n pi becomes 0. So this entire thing becomes 0. That is, an again becomes 0 as expected. Next you write to find Bn. Bn is equal to 1 by pi integral f of x sin nx dx between the interval minus pi to pi. We are going to do the same thing here. That is 1 by pi integral minus pi to pi x. This time it is a sine function. Again, let me keep this as first. Let me keep this as second. 1 by pi as it is I am going to write. First into integration of second, that is minus cos nx divided by n minus pi to pi minus integration of second is this itself, that is minus cos nx divided by n integration of second into differentiation of first. Differentiation of first is dx minus pi to pi. Now Bn equals 1 by pi. Start applying the limit. Keep this minus outside. I am keeping this minus outside here. X is pi, cos nx is cos n pi by n minus pi cos minus n pi by n, okay, minus. I am taking this minus into minus as plus. Now this minus is gone. We are supposed to do integration of cos nx by n between minus pi and pi, right? I am taking 1 by n outside. Integration of cos is sine. So sin nx divided by n minus pi again to pi. Next, Bn equals 1 by pi. Here you have pi by n cos n pi. This minus into minus becomes plus pi by n. Cos minus n pi is cos n pi. So cos n pi. Hope everything is clear to you, students. Plus 1 by n. Next, I am taking this n and multiplying along with this. So it becomes n square. Applying the limits we have sin n pi minus sin minus n pi. Okay. So 1 by pi. This is minus 2 pi by n cos n pi. Actually, I am not supposed to write 2 square bracket. Okay. So this is the first term. The second term. What is sin n pi minus sin minus n pi? Though it becomes 2 sin n pi, just start giving values for n. Let's say n is equal to 0. Sin 0 is 0, right? N equals 1, sin pi is 0. Again, n equals 2, sin 2 pi is again 0. Sin 2 pi and sin 0 are same, right? Because it has completed one full rotation and it has gone back to 0. If it is 2 pi and 0 are one and the same. Except that it has completed one rotation here. Here it's just starting. Okay. So this entire term becomes 0 and Bn is this. Pi and pi gets cancelled. We are left with minus 2 by pi cos n pi. Now, just like we understood what is sin n pi, let's check what values can cos n pi take. Let's say n equals 0, cos 0 is 1, n equals 1, cos pi is minus 1, n equals 2, cos 2 pi is 1, n equals 3, cos 3 pi is again minus 1. So it goes on like that, right? So if you take cos, in general, if you take cos n pi equals, I can take it as, see, for all odd values, it's taking negative values, and for all even values, it's taking plus 1, right? Now if I take n equals 4, say, cos 4 pi will be plus 1. So for all even values, it's taking plus 1. For all odd values, it's taking minus 1, right? So I can write cos n pi as minus 1 whole to the power of n. Bn becomes minus 2 by pi minus 1 whole to the power of n. I can take this minus as minus 1 times minus 1 whole to the power of n times 2 by pi. Again, Bn can be minus 1, don't you think I can write it as, if there is nothing in the power, it's considered as 1, right? It's read as 1. Minus 1 raised to 1 multiplied by minus 1 raised to n will be minus 1 raised to n plus 1. 2 by pi, right? Now, again, the final solution is depending on the value of n. Let's take for all odd values of n, Bn will be, how do we understand odd values? N is taking odd values in the sense 1 plus 1, let's say 2 by pi. So 1 plus 1 is 2, that is, it remains 2 by pi, or it could be odd value of n. Next, the next odd value of n will be 3 plus 1, 2 by pi. So minus 1 to the 4 will be plus 1. So again 2 by pi. For all odd values of n, Bn remains 2 by pi. For all even values of n, Bn, let's see what it becomes. Even values of n means 2 plus 1, 2 by pi. So minus 1 to the 3 is minus and 2 by pi. The next even value is 4. 4 plus 1, which is 5. Minus 1 to the 5 makes minus 1 itself. So it is minus 2 by pi. So for all even values of n, Bn is minus 2 by pi. So our final answer should be like this. The Fourier expression is, the Fourier expression for f of x equals x is f of x equals a0 was 0, an is 0. Next term will be summation over n equals 1 to infinity. Bn, right? What is value of Bn? Minus 2 minus 1 to the n divided by n sine nx. On solving this we get f of x equals, put n equals 1 here, you get 2 divided by 1, right? Sine 1x plus, put n equals 2, you get minus 1 whole to the power of 2 will make this positive. This remains minus, which goes here. So minus 2, n is taking 2, right? Divided by 2. This becomes 1 no. Sine 2x plus, again there is a minus 2 and minus 1 whole to the 3 gives minus 1. So minus 2 into minus 1 is plus 2 divided by, n is taking value 3 now. So sine 3x. So again there is a minus over here. So it goes on. So the final Fourier expression is 2 sine x minus sine 2x plus 2 by 3 sine 3x minus etc. You can go on, you can write 4 to 5 terms, but this is sufficient. Alright. So this will be our final solution. To save time, you don't have to go through the derivation of an and a0. You don't have to do all these things. You can just say what I said in the beginning. You just say for odd functions, a0 equals 0, an equals 0. You can say this and you can go ahead and find out Bn to save time. Because this question is only for 4 or 5 marks. You can just skip this entire work which goes into finding out what is n0 and an. You don't have to do that in exam. You just start from this part. You can start from here and go ahead. Alright? All the best.